Welcome back. Remember our final project? Based on what we've learned, we know we should use PM2 to take full advantage of all the CPUs in our server machine. How might we apply this to our NASA API? Our API doesn't have much long-running blocking code. We've been fairly smart about that. It can safely handle thousands of requests. However, at some point, the bottleneck will become the CPU and how many requests per second we can handle on the single-threaded event loop, right? Just like this IKEA bottle, the neck part determines the overall fastest rate at which water can flow out of it. The width or capacity of the rest of the bottle doesn't matter if the bottleneck is holding it back. So if the single CPU running our project API becomes the bottleneck, we need to try to set up a cluster with our NASA API running on each worker in that cluster. What we can do is go into our project's server folder. So we'll cd in our terminal to server and run npm install pm2 as a local project dependency and not as a development dependency. Now that PM2 is available in our server, let's update our package.json and add a cluster command that will run in production when we need the maximum performance from our server. So let's say that the cluster command will run pm2 starting our source/server.js, just like our other commands. And we'll start it in cluster mode using the -i flag with the maximum amount of workers to match the amount of CPUs that we have. PM2 is available in our package.json because it's been marked as a dependency when we installed it. So now in our package.json, in our project root, we can create a version of our deploy command here. Let's take that and copy it. And we'll say that deploy-cluster will do what the deploy command does with building the client and then starting the server here. But instead of npm start in the server project, we're going to run npm run cluster, which is the command that we just added. Let's see if our cluster works. I'll go back, and in the root of our project, we can now do npm run deploy-cluster. Notice building the client side, the front end. That's been completed, and we've started our backend cluster that's serving both our client and our API. So now in the browser, let's go to our project URL. Localhost on port 3000, or was it localhost on port 8000? That's the one. There's our beautiful dashboard. We can now create launches and send them to our server running on each of those worker processes. And if I go to my upcoming tab now, I should see all of my launches that I've created, right? We have one scheduled for December 27th and one on March 29th. Well, let's keep creating launches. I'll make one more for June. And submit that. And wait a second. What happened to the other launch that we just created? We're only getting the hard-coded launch that we had before, and the one that we just submitted that's scheduled for June 2023, but not the third one, which we expect to see. And it's definitely not in our history because we haven't aborted that launch. What's going on? Something about our cluster is making our dashboard seem like it's not saving the launches that we create. Let's get to the bottom of this mystery. Where are our launches being saved? That was happening in our source folder, the one in our server, /models and the launches model, where we keep this map of launches in memory while our process is running. In the memory of our node process for the duration as long as that process is running. When we run our NASA project as a cluster, we now have multiple processes that are each storing a map of launches in their individual memory, and that memory isn't being shared. So if I send a request to save a launch to one process, and then I submit another request to get the launches, there's no guarantee that those two requests will talk to the same server, to the same process. For our clusters to work, and for any of our horizontal scaling approaches to work. Remember, when we add many servers together to each share the load for part of the requests that come in, we need to make sure that our server is what's called stateless. None of these servers can store state on them individually because there's no guarantee which server will handle a request coming in. The solution is to remove the state from our server's memory and persist it somewhere else. Somewhere like a database that lives independently outside of our node processes. So for our launches model, for example, we need to move this launch data, and rather than storing it in a map in memory, we need to store it in some database. A database that will have the added benefit of keeping our data around even if our server crashes or we have to restart it. We'll find out how to work with databases and persist our data very soon. I'll see you in the next video.